In this video, we'll take a look at creating a counterbore hole. One option is to use Hole Wizard. When creating specialty holes, drilled holes to depth, tap, threaded, counterbore, countersunk, Hole Wizard is a good option. I will show a variation to this, especially if you're creating one, maybe two counterbored holes that you could opt to use. So the part that we are referencing is the index feed. It's the first time in my CAD classes that we're seeing a counterbore hole. Take note that this part is in inches. The drill diameter, that is the smaller diameter, is a 1/2 inch, which goes all the way through. There is no depth specified for the drill. The counterbore is 3/4 of an inch and is 0.38 inches deep. The counterbore has this recess so that the shaft of the bolt will go through and then the head of the bolt will sit on top. It will be recessed from this top surface. So two different diameters. They are concentric, which means they share the same center. We have our horizontal and vertical placement, which is 0.75 back and 125 plus 0.38 in from the side. So we'll need all this information to create this. So let's take this off. So you got to this point, and now you need to create the counterbore hole. So normal 2 would be a good option, and we're going to activate Hole Wizard. I guess I should slow that down a little bit. Hole Wizard is in your features toolbar. And Hole Wizard, first off, is asking you for which hole type: counterbored, countersunk, drilled to depth, straight tap, tapered tap. I don't know them off the top of my head. A slot. Yeah. Well, either way, we want a counterbore hole. One, I wouldn't say glitch, but one thing that you have to be aware of when using Hole Wizard is that the units do not automatically sync to the unit that you are using in the workspace in designing the part. I can switch back and forth from inches to metric. So you got to make sure that you are typically in matching units. So in this case, with it being inches, I want to stay with inches. Most times, custom sizing allows you to input your own dimensions. There is a wide variety of options. Custom sizing is probably quicker than trying to scroll through and find the size that you're looking for. So the first thing it's asking me for is the hole diameter. And our hole diameter on this one is 0.5 or 1/2 inch. Our counterbore diameter is 0.75 or 3/4. And our counterbore depth is 0.38. Our end condition. In this case, the drilled hole goes all the way through, not blind. I mean, up to surface would work in this case, but through all is already selected. In this one, we have no options. We don't have head clearance, countersinks. So all we need to do now is place the hole. So positions. Somewhere on this surface, I'm just going to drop one into position. You will notice that your toolbar has changed to the sketch toolbar, which will allow you to smart dimension. In this one, you have to pick the center. Unlike dimensioning sketch circles, where you can just select the circumference, you have to pick the center. We are 0.75 inches in from the front, and this one is mathematically driven 1.25 plus 0.38, and I have positioned my hole left to right, top to bottom. I'm going to orbit. I'm getting my preview, and I'm done dimensioning, and I am done using Hole Wizard. and I have created my counterbore hole. In the instance where you only have one counterbore hole, there is another option. The problem is if you are dimensioning this hole later, hole call out, which is how we dimension these specialty holes, doesn't always follow through. So using Hole Wizard is definitely your better bet. Another option is to create one of these features. Whether you create the counter bore with just a sketch, here's my horizontal, vertical placement, and my diameter for my counter bore. I did the counter bore first, and then I cut that to a specified depth of 0.38. I can then come back and reference. If I hover over this circumference, I'll get the center point, and then I can create my half-inch diameter and drop it all the way through. The order in which you would do these does not particularly matter because they are concentric. So let's take a look at one of these quick. I'll do the drilled hole in this case first, since I just showed you creating a counter bore first. I have a surface that I'm going to sketch on. I'll place my half-inch diameter circle, and I'll set my horizontal and vertical distance. Um, 1.63, and it's a half-inch diameter for the drilled hole. So the drilled hole goes all the way through. No depth is specified, so it's known that it goes through. Since they are concentric, you don't need to add the relationship, because if you hover over the circumference, you'll find the center. This eliminates the need to measure the horizontal and vertical distance. The outer diameter, or the counterbore diameter, is 0.75, and this is cut to a blind depth of 0.38. So if you had one, maybe two counterbore holes, this might be actually faster than setting up Hole Wizard. But if I had 3, 4, 5 counterbore holes, using Hole Wizard would definitely be faster and more accurate because all your hole dimensions are the same. So creating a counterbore hole using Hole Wizard.